Awesome. Okay. So now we are going to talk about rational exponents, which are exponents that are fractions. So we still have our laws of exponents notes nearby, but we want to begin with this little section of this paper here because I did not leave enough space in this little box to explain all the things that need to be explained about rational exponents. So let's start here and begin with the fact that everybody knows 3 times 3 is 9. What a great place to start. So when we talk about powers, or exponents, exponents are the little tiny numbers that are up in the right-hand corner, but powers are sort of this whole process of evaluating exponents. So when we think about that, we're thinking about repeated multiplication, like multiplying the same thing times itself over and over again. So for this basic example, we can say 3 squared equals 9. So we can say that 9, just using some funky language here, 9 is 2 powers of 3. So that's not scary. 9 equals 2 powers of 3. So powers of 3, 2 of those. Just showing you how these words kind of connect to these expressions that we're doing. So if we reverse that, describing 9 as powers of 3, we can describe 3 as powers of 9. So we would say 3 is half a power of 9. So 3 equals half a power of 9. So 9 to the 1/2. And there's our first time we're probably seeing a fraction as an exponent. So let me show you another something. Let's talk about this a little more here. So if 3 equals 9 to the 1/2, and we know that 3 times 3 equals 9, let's substitute, draw an arrow up here. So we're going to apply this fact to this original fact that we started with. So if 3 equals 9 to the 1/2, then we can rewrite 3 as 9 to the 1/2 times 3, so another 9 to the 1/2. So 9 to the 1/2 times 9 to the 1/2 equals 9, which 9 without an exponent means the exponent is a 1. And when we multiply powers that have the same base, we add the exponent. So we're adding 1/2 plus 1/2 equals 1. And, math makes sense. Yay! So, what we have basically kind of established here is that 3 times 3 equals 9, and 3 squared is 9, and 3 is 9 to the 1/2, and we knew that, but we're used to seeing that as the square root of 9 is 3, meaning if we see a square root, we start thinking what number times itself equals 9, and then we come up with 3. So that means that if you have an exponent of a half, so let's put in a little something there so that we know, like, something to the 1/2 and taking the square root of something are exactly the same thing. They just are written different ways. So, new fun fact, x to the 1/2 is the same thing as the square root of x. And it follows that a cube root, which whatever root you're taking, the little number appears right there, except for a square root because that's the most basic one. So sometimes you see a 2 written right there, but it's just kind of implied that it's a square root if you don't see a number. So a cube root is the same as taking something and raising it to the 1/3. So x to the 1/3 equals the cube root of x. And the cube root of x, we would evaluate that by thinking to ourselves, what number times itself again. So multiplied 3 times would give you that result. So let's do some examples so we can start to see. 9 to the 1/2. Well, start thinking that if you see a 1/2 as the exponent, that's the same thing as a square root. So that's the same thing as the square root of 9, which is 3. Okay, if we were solving an equation, we would do plus or minus 3, but since we're just doing an expression here, we can just say it's 3. X to the 3/4. So this is like a total out of nowhere one. So this was a square root. Let's go ahead, let's skip this one. Do the 8 to the 1/3 first. So 8 to the 1/3 we know is the same as the cube root of 8. And can you think of something that when you multiply it by itself 3 times, it equals 8? Because it's 2. 2 times 2 times 2 is 8. So the cube root of 8 is 2. So if we had a cube root being an exponent of 1/3, if the denominator here is 4, this means we're going to have a 4th root. So go ahead and draw a 4th root symbol. And then it's 3/4. So the top of the fraction, the 3, means our x is going to be cubed. So we're cubing x and we're taking the 4th root. So here's another way of thinking about this. We have to be a little fancy with our laws of exponents. We know that if we, let's just suppose we took this and rewrote it as x to the 1/4, and then put parentheses around that, to the 3rd power. So I just rewrote 3/4 as 3 times 1/4, because when we raise a power to a power, we multiply. So if I put this back together, it would give me x to the 3/4, because 3 times 1/4 is 3/4. So this just shows you how the denominator becomes the root. So here's my 4th root, and then I'm cubing the 4th root. So there's 2 ways of writing this. You can put the 3 in here, or you can put the 3, there we go, out like this. Because it doesn't matter if we think of doing x to the 1/4 to the 3rd, or if we think of doing x to the 3rd to the 1/4. Those will come out the same, because you're just multiplying the exponents. And you can multiply numbers in any order that you want, because of the commutative property. So, that was a lot. Let's go to this example here. 25 to the 3/2. So the denominator is our root. So we're going to take the square root and then we're going to cube. So we have the square root of 25 and then cubed. the square root of 25 is 5, and 5 cubed is 125. I like doing it that way better, where I take the root first and then cube, because it makes the number smaller before you have to make it bigger again. So let me actually grab a calculator here and show you where to find some of these buttons. So the cube root button, oh no, okay, well, it's under math. So if you push math, it's the fourth one down, the cube root. So you can take the cube root. We're not doing cube root. I'm sorry, we're doing square root. But now you know where to find cube root. So you can do square root, which we know where that is, second x squared. You can do the square root of 25, and then to the power of 3, and get 125. Or you could reverse the order, and you could take 25 to the power of 3, which you'd have to have a calculator to do that because that's such a big number. Then you would take the square root of that number, and you would get 125. So in this instance, it doesn't matter whether you do the root and then do the exponent, or do the exponent and then do the root, because those are really the same process, because they all are in the realm of exponents in the order of operations. So, last example here. So we have the same base of x, and we have division. We also know that if we don't have an exponent that is visible, there is an exponent of 1. Let's put this over a little bit. Okay. So we're going to divide, so we subtract the exponents. So this would be simply whatever x, and then we have 3 halves, and we're subtracting 3 halves minus 1 to find out what exponent we will use for x. So 3 halves minus 1 leaves us with 1 half. So we have x to the 1 half, which is a perfectly fine answer, or we now know that x to the 1 half is the same as the square root of x. So whichever one of these you're more comfortable working with is fine. So let's just fill in real quick. Let's go back to the Laws of Exponents paper. Way too zoomed in. And go to the bottom. So rational exponents. Rational means fractional, because we're writing things as a ratio. They can be written, with a fraction as the exponent, or using radicals, which are the same. It's another word for roots. So here we have our very general thing. So if you have b to the x over y, it's equal to the y root of b to the x. So the bottom becomes the root, the top becomes the exponent if you're moving to this root form. So think of it as like the roots of a tree. You have a tree. Very good tree. The roots of the tree are on the bottom. So the bottom of that exponent fraction is going to tell us what root to take. Let's just do a couple examples, since we have that other paper explaining a lot of the theory. So if we have b to the 4 thirds, that's the same as the third root of b to the 4th, or the